All right, so I got a copy of last spring's 2015 exam. This is the exam they took last spring. We've made some modifications to it, only things to help you guys out with it. But this is basically what you guys are going to be looking at. Now, you guys have your exam tomorrow at what time? What time do you have to be at the exam room? About 7:30, and don't forget to bring your student ID card because we got to pass out a bunch of papers for you guys, and you got to bubble in your op scan sheet and all this other stuff. So it takes a few minutes to get organized. Right at 8 o'clock is when you get to, quote, open the exam booklet. Now, the common exam for the college algebra class is going to be 100% multiple choice. And there's going to be 40 multiple choice questions. This seems to be the standard for the last 3 years. We're going to have 40 multiple choice questions. On the front part of your exam booklet, they're going to give you your basic form. So in case you've missed something, forgot something or other, check up here. But there's no explanation about what it is and what it does and how to use it. You're expected to know all that good stuff. So the big difference between the exam that we're about to take right now and the exam you guys will be given tomorrow is one big thing. If you open your exam booklet, we start taking the exam, the one problem with this exam was this. They didn't give you much room to do the work on. We fixed that for this semester. So instead of having this little bitty space for question one, you'll have like this amount of space for question one. We killed some trees to give you guys a chance to actually work the problems on the test. So the questions will be a lot longer. So you'll know what I'm going to do here is I brought some extra paper here, and I'm going to actually do the problems. If I need the work, I can probably do it on the test, but to make it more organized, if I need it, I'll have some extra sheets of paper and stuff. So let's go ahead and take this exam. But again, the reason why you're studying this exam is to remind you, one, how to do it, and especially the formulas you need to have memorized for this thing. And so, I mean, we'll give you some formulas, but that doesn't mean we're going to give you everything. You got to know how to do this stuff. So, here we go. Let's take a look at this first question. Simplify the expression. I got 4x to the 6, y to the negative 2 raised to the 1/2 power, divided by x times y to the negative 4 squared. Okay? So here we go. The first thing I would do on this particular problem is, if I got something being multiplied together in the numerator, raised to a power, I'm going to strict multiplication division, I get to distribute the power. So this would be 4 to the 1/2, x to the 6 to the 1/2 power, y to the negative 2 to the 1/2 power, divided by, in the denominator, I'm going to distribute that as square, so that's x squared, but it's y to the negative 4 squared. Again, the big complaint was very little room to do this problem. But here's the deal. Again, reminding you about the work. A power raised to another power, what do I get to do with the powers? Multiply. Leave your constants alone. So that's just a constant. I'll come back later and clean him up. That's just 4 to the 1/2. Now here's my power. X to the 6 to the 1/2, power to a power multiply. 6 times 1/2 is 3, that'll be x cubed. Y to the negative 2 times 1/2 would be negative 1, divided by x squared. Y to the negative 4 squared, power to a power multiply, that'll be y to the negative 8. Now, let's clean up some stuff here. Let's talk about that constant for a second. What is a 1/2 power also known as? Square root. So 4 to the 1/2 power is the same thing as the square root of 4. And what's the square root of 4 equal to? 2. So this would be 2x cubed. Now, the other thing I want to clean up is this, negative exponents. If I have a negative exponent in the numerator, to clean them up, it'll show up in the denominator as a positive exponent. If I have a negative exponent in the denominator, that will clean up and flip up and be in the numerator with a positive exponent. So, the y to the negative 1 will show up as y to the first on the bottom, and y to the negative 8 will show up as y to the 8 on the top. Now, the last thing, let's divide. What exactly is x cubed divided by x squared? When you divide, what do I get to do with the exponents? Subtract. 3 minus 2 is 1. So this would be 2 times x to the first. Now let's talk about the y's. I got y to the 8th divided by y. What is that going to give me? Y to the 7th. So the answer is 2x times y to the 7th, which is the answer B. Again, practicing your quote properties of exponents. Does that make sense? Take a look at the next one. Factor the polynomial completely. Now, most of the polynomials you guys are going to be factoring tomorrow are going to be quadratics. They just love quadratics on you guys. However, on this particular problem, how many terms do I have on this one? 1, 2, 3, 4. Anytime you want to, quote, factor completely a polynomial that has 4 terms, the number one technique is something called factor by grouping. When you got 3 terms, you do the anti-full stuff. But when you got 4 terms, you're going to do the factor by grouping. So, I've got x cubed minus 25x plus, minus 4x squared minus 100. And they set it up for this factor by grouping. They want you to factor the first 2 terms together and factor the last 2 terms together. Now, what do you have in common on an x cubed minus a 25x? What term do you have in common on those 2 terms? An x. Factor it out. So that'll be x times x squared minus 25 when you pull it out. Now look at the other terms. Minus 4x squared minus 100. Wait a minute. That should be that's plus 4x squared. Sorry about that. Minus 100. What do you have in common that you could pull out on both those 2 terms? A 4. So pull out the plus 4, and you're left with an x squared minus. When you take 4 out of 100, what do you got? 25. 100 divided by 4 is 25. Now, factor by grouping is this. When you look at these terms, you should see the same thing in both terms. You went from 4 terms to actually 2 terms. Terms are separated by pluses and minuses. So I can factor that guy out. That's an x squared minus 25, and I pull it out of both terms. I'm left with out the first term an x, plus out of the second term a 4. But you're not done factoring. One last thing to factor, and that's that x squared minus 25. That's called a difference of squares, a classic way of factoring. How does x squared minus 25 factor? X plus 5. X plus 5 times x minus 5. Difference of squares times the x plus 4. And this is factored completely, which is which answer? X plus 5, x minus 5, x plus 4. The answer is D. All right. You know you're going to see one of these problems on your test. Solve the equation. I got 3 bracket negative 3x plus 4 minus 7 parentheses x plus 1 close parentheses close bracket equals 2x plus 5. Basically, to solve for x, I want to get x by himself. The first thing you should do is clean up inside the parentheses and try to get rid of parentheses. So, if I was cleaning this thing up, the first thing I do is work inside my parentheses, and I would distribute that negative 7. Take your time. How long you got for this exam? 3 hours to do 40 questions. Let's do some math. You got 3 hours. How many hours? Quit. There we go. 3 hours, but there's 60 minutes an hour. So you got 180 minutes. There are 40 questions divided by 40. That gives you 4.5 minutes per question. Most of the questions you're going to be able to do in about a minute or less. Okay? But there's going to be a few of those problems on there that's going to try to make you think and work it out. And those, well, then you've bought yourself some extra time. So you've got all the time in the world. Sit back and enjoy this thing. You've got no place to go. It's 8 o'clock in the morning. My goodness. Just wake up, most important, and do the exam. So when I clean this thing up, this will be 3 times bracket, negative 3x plus 4, minus 7x minus 7 when I distribute, close bracket, equals 2x plus 5. I'm going to combine like terms. This is 3 times negative 3x minus 7x is minus 10x. Plus 4 minus 7 is a minus 3. Close bracket equals 2x plus 5. What's my next move? The ultimate goal on trying to solve is get rid of any kind of parentheses and stuff. I'm going to distribute again. This will be negative 30x minus 9 equals 2x plus 5. Now, how am I going to solve for x? I'm going to, quote, get all my x's on one side, so I'm going to go ahead and subtract 2x from both sides. This would be minus 30x minus 2x is a minus 32x. And then I'm going to add 9 to both sides. And that would be 9 plus, so 5 plus 9, which is 14. And then the last thing I'm going to do is divide, in this case by negative 32. And I'm going to reduce my fraction. A positive divided by a negative is a negative. 14 over 32, I can reduce it by a factor of 2. So 14 divided by 2 is 7. 32 divided by 2 is 16. I got negative 7/16, which is answer E. And of course, for you guys, remember, this is a multiple choice test. What kind of partial credit do you guys get on a multiple choice test? None. So make sure you get the right answer. So if I got 14 divided by negative 32, I put it on the calculator, and then I can use the old math fraction button just to make sure I didn't make a careless error. Watch the careless errors on this thing. Here's what we call one of those complex fractions here, complex rational expression. We want to simplify this thing. So I've got 9 plus 3 divided by x over 4 plus 1/12. A, quote, complex fraction is a fraction where you have fractions in the numerator and fractions in the denominator. So fractions of fractions. To clean it up, you want to get one big fraction in the numerator, you want to get one big fraction in the denominator. But to get a fraction, you got to have a common denominator. 9 is officially the same thing as 9 over 1. And I got 3 over x. What's my denominator? What's my only denominator, really? X. Since the x was already in the term 3 over x, I don't get to do anything to the numerator. But if I want to put an x in the denominator of the 9, whatever I do to the bottom, I got to do to the top. So 1 times x is x, and then I got to do a 9 times x, which makes it 9x. Whatever I do to the denominator, I have to do to the numerator. I'm multiplying the bottom by x, so I have to multiply the top by x. Divided by, now look at this expression. X divided by 4 plus 1/12. What's your common denominator between x over 4 and 1/12? What's your common denominator between 4 and 12? 12. So my common denominator is 12. Since this 1/12 I already had the common denominator, I didn't have to do anything to the numerator. But what do I have to do to a 4 to make it into a 12? Multiply by 3. So whatever I do to the bottom, I do to the top. That gives me a 3x in the numerator. Now we're going to write it as one big common denominator, which will be 9x plus 3 divided by x in the numerator, divided by 3x plus 1 divided by 12. Now what do I do when I have a fraction divided by a fraction? Multiply by the reciprocal. For the rest of us, we just flip and multiply, right? But remember, things only cancel through strict multiplication division. So this would be 9x plus 3 over x times, invert multiply, 12 over 3x plus 1. But right now, nothing's going to cancel because I got pluses going on in my denominators and my numerators and stuff. The only way to cancel is strict multiplication division, which means before you can cancel it, factor it out. What can I factor out of a 9x plus 3? A 3. That would leave me with 3 times 3x plus 1 over x times 12 over, there's nothing I can factor out of the 3x plus 1, so I'll just put parentheses around it, 3x plus 1. Okay? Now, what cancels here? 3x plus 1's canceled, leaving me with a 3 times 12 over x. And what's 3 times 12? 36 over x. So that is my solution, 36 over x, which when you go back and look at your answer set, that is answer A. I'll do my best on trying to do the problems actually on the sheet here, but they really didn't give you much room. So trust me, tomorrow's exam, we expanded the thing out to make sure you got plenty of room to do all your work right there with the problem. So keep up. So you won't have to use as much scrap paper and stuff. Solve the equation. But look at this equation, slightly different from the other equation. I've got 4 divided by x plus 7 equals 1 over 2x plus 5. You know, when I'm simplifying, I want to get a common denominator. But on something like this, it's an equation. When I have an equation, I don't want to get a common denominator. I want to eliminate denominators. I don't like fractions. But with equations, you got the ability to get rid of it. You get rid of a fraction by multiplying by the entire equation by the common denominator. Look at your denominators. I've got x, that's officially 7 over 1. I got a 2x, and I got a 5. What is the common denominator between an x, a 2x, and a 5? What big number that all these terms divide into? 10x. It's the 2, the x, and times the 5, that's 10x. So I'm going to multiply every term by 10x. X, 10x divided by x, the x's cancel. I'm left with 10 times 4, which is 40. 7 times 10x would be plus 70x. 2x, so I got 10x times 1 over 2x. 2x goes into 10x how many times? 5, and 5 times 1 is 5, so that'll be equals 5. And here we go, the last one. 5 goes into 10 2 times, and 2x times 14 is going to be what? 28x plus 28x. So, down here, just cleaning it up, I've got, just going to rewrite it, 40 plus 70x equals 5 plus 28x. Well, to solve for x, so I'm going to get all my x's on one side, so I'm going to subtract 28x from both sides. And at the same time, I'm going to get all my y's on the other side, I'm going to subtract 40 from both sides. So the 28x's cancel here, and the 40's cancel here. This is going to leave me running it this way. All right, 70 minus 28. What is that? 70x minus 28x is 42x. 42x is equal to 5 minus 40, negative 35. Sorry. Now, what have I got to do to solve for x? Divide by 42. On both sides, so I get x is equal to negative 35 over 42, but that's clearly not one of my answers here, but I can reduce my fractions. 35 and 42, both of them have a factor of 7, so what is that going to be? 35 times, which is negative 35, which is 5 times 7, 42, which is 6 times 7, that makes it reduced to negative 5, 6. Answer C. But let's just double check that on the old calculator. Never make a careless error. Negative 35 divided by 42 converts to a fraction of negative 5, 6. All right, take a look at this next guy. And if you have a question, let me know. And again, I'm trying to squeeze this all into there, but it does make it like I'm running everything together here, which I really am. So let's just do this here. All right. Look at this problem, number 6. Which of the following statements below describes the solutions to the equation 2x squared plus 5x equals 3? Stop, pause, hesitate, and ask yourself, what kind of equation do I have here? Quadratic. And they're talking about, they didn't ask me to solve it, but they asked me the type of solutions. So, tell you what what I'm going to do here is, because based on their answers, there are two solutions, both positive, one's negative. I might as well just go and find out what the solutions are and then answer the question. They're just making me jump through one other hoop instead of solve the thing. But how do you solve a quadratic equation? First thing you should do is what? Set it equal to your favorite number, which is 0. Good. So I'm going to subtract 3 from both sides. That gives me 2x squared plus 5x minus 3 equals 0. The next thing is this. Does it factor? If it factors, factor. If it doesn't, you have a special formula, which is called the quadratic formula. This one, I believe, is going to factor. I don't know. Let's just double check it here. I'm going to try to factor it. How does 2x squared factor? 2x squared is going to factor into 2x times x. How does a 3 factor? Only one way, 3 times 1. But that outer inner folding thing, I've got to get, it's a minus, so I've got to subtract up to get 5. And if I multiply a 2x times a 3, that gives me a 6. And a 1 times x is a 1x, so 6x minus 1x is a 5x. So this thing does factor. I get 2x times x, and I want to multiply the 2x times the 3 on the FOIL, and I want to put the 1 there. Because it's a minus, they'll have opposite signs. Because the middle term is positive, the bigger number, when I fold it out, would be positive. The bigger number would be the 2x times 3. So the 3's got to be positive, the 1's got to be negative. I'm going to set it equal to 0 and solve. Now, when you're doing this stuff, careless errors kill with this mess. So if I'm not sure about my factoring, fold it back out just to double check. 2x times x is 2x squared. 2x times 3 is a positive 6x. 1 times x is negative x. 6x minus x is 5x. And negative 1 times 3 is negative 3. So this did factor properly. Then you set each factor equal to 0. X minus 1 equals 0, and x plus 3 equals 0. Then solve for x. Add 1 divided by 2, x is 1/2. Subtract 3, x is negative 3. So in terms of my answers, I have got one positive answer and one negative answer. So there's one solution. Nope, there's two solutions on this thing. Both positive, both negative, and then both C. There are two solutions, one positive and one negative. The answer is C. Take a look at the next guy. Again, as you're doing these problems, also make mental notes of any kind of formulas that I'm using. Solve the inequality and express the solution in interval notation. So here we go. I've got the equation 0 is less than or equal to 2 minus 3x, which is less than 2. This is what I call one of these double-sided inequalities. When you have a double-sided inequality, you want to solve for x, but you want to solve for x where? In the middle. So how am I going to solve for x in the middle? What's my first move on this thing? Subtract 2. What I do to one side, I do to the other. This has two different sides. So what I do to one side, I do all sides. I'm going to subtract 2 from all sides. 0 minus 2 is negative 2. This cancels. So it's less than or equal to negative 3x, which is less than 2 minus 3 is negative 1. Now what's my next move to get the x in the middle? What do I have to do to get that x by himself? I am subtracting, 2. Thank you. 2. And that would be a 0. I can't read my own handwriting. That would be like negative 0, which is also not 0. Thank you. Watch my careless errors. But now, this is what I was really after because I'm actually 3 steps ahead thinking about supper. But here's the deal. I got negative 2 is less than or equal to negative 3x, which is less than 0. What's my last move to solve for x in the middle? I'm going to divide by negative 3. And something should scream at you besides me about dividing by a negative number on an inequality. Switch to signs. If you multiply or divide by a negative number, you got to switch the sign. So I'm going to divide by negative 3. And that negative 2 divided by negative 3 is 2/3, but I got to switch the sign. So this less than or equal to becomes greater than or equal to. This cancels. I'm left with x, which is greater than 0 divided by negative 3. When 0 is on top, it's 0. And this is my answer, but there's a problem with this answer in the quote set notation. The fact is that in set notation, we always like to have the small number on the left and the bigger number on the right. The problem is, we read math like we read English from left to right. From left to right, it's 2/3 is greater than or equal to x, which is greater than 0. But you can also read it from right to left. And right to left, reading it this way, would be 0 is less than x, and I'll write it like this. 0 would be less than x, which is less than or equal to 2/3. And that represents how the number line would be. Small numbers on left, big numbers on right. But now they want it in interval notation. Does that have an equal to on it? So without an equal to, we use parentheses. So this would be parentheses 0, 2/3, but that does have an equal to. So how do I denote an equal to? Bracket. So the answer set would be parentheses 0, 2/3 bracket. 0, parentheses, bracket 2/3. So the answer would be D. Does that make sense? Find the slope of the line that passes through the points -2, 3, and 4, 3. Now, if you need it, the formula for the slope of a line is on that front page of your exam. But the fact is, you should have this thing memorized. What's the formula for the slope of a line? y2 minus y1 over x2 minus x1. This is my first point. This is my second point. So y2 would be 3 minus 3 divided by 4 minus -2. 4 minus -2. Well, this is easy math. What's 3 minus 3? 0 divided by 4 minus -2. Minus makes it plus 6. What is 0 divided by 6? 0 on top, it's 0. 0 in the denominator does not exist. No solution. But the 0 is in the numerator. 0 divided by 6 is 0. So the answer is B, 0. Does that make sense? Again, trying to give you guys hints on trying to prepare for your final exam. They're going to hit you hard on the equations of lines. So make sure you guys go back and practice equations of lines. They're also going to hit you hard on quadratics. They just love quadratics in this class. But also, they're going to hit you hard on lines. Find the equation of the line that's parallel, perpendicular, and all that good stuff. Make sure you practice that. What is the slope and y-intercept of the equation 3x minus 2y plus 6 equals 0? This is what we're known as general form. Has no purpose in life except it looks good to put everything on one side of the equation and set equals 0. If they're asking me about slope and y-intercept, I like to use the slope-intercept form. The slope-intercept form is used for two reasons. It's used to graph and to read off data. The slope-intercept form is what everybody remembers as y equals mx plus b. Basically, take this equation and solve for y. So as I got 3x minus 2y plus 6 equals 0, I'm going to get my y by itself. I'm going to subtract 3x from both sides, and I'm going to subtract 6 from both sides. This cancels and this cancels, leaving me with a -2y is equal to a -3x minus 6. Now to solve for y, what am I going to do? Divide by -2. What I do to one side, I do to the other. What I do to one term, I do to all terms. This cancels, leaves me with y equals -3 divided by -2 is a 3/2 x. Minus 6 divided by -2 is a plus 3. And the old y equals mx plus b, my slope is 3/2, and my y-intercept b is 3, or as the point, it would be the point 0, 3. The b is the y-intercept or the y-coordinate, 0, 3. So, my answer is, slope is 3/2, the y-intercept is 0, 3, b equals 3. So the answer is C in this problem. Does that make sense? Find the equation of a line that is perpendicular to the equation 2x plus 3y equals 4 that passes through the point 4, 6. What do you guys know about parallel lines? Parallel lines have what? Same slope. What do you guys know about perpendicular lines? negative reciprocal slopes. Flip the fraction and change the sign. But to figure out the slope is when I want to put things into slope-intercept form. So I have here, I'm going to solve this thing for y to figure out the slope. I'm going to subtract 2x from both sides. That gives me 3y is equal to negative 2x plus 4. Then I'm going to divide by 3 on all sides. And that gives me y equals negative 2/3 x plus 4/3. So my slope on this problem is negative 2/3. What does that imply that my perpendicular slope, and the symbol for perpendicular is an upside down T. What would my perpendicular slope be? Flip the fraction, change the sign. Very good, 3/2. So there's my slope. And I have the point. And remember this, anytime they ask you, they being the people who make up the final exam, ask you to find the equation of a line, which form of equation of a line do you always use to answer the words, find the equation of a line? Point slope formula, which is y minus y1 equals m times x minus x1. The point slope formula. It's the one that nobody remembers, but it's the most important equation of a line. The point slope formula, because you have two things to find the equation of a line, a point and a slope. Well, there's the slope, and there's the point. So I've got it covered. So plugging it in, y minus my y coordinate, I got the 0.46, the y coordinate is 6, is equal to my slope, which is 3/2 times x minus the x coordinate, which is 4. So they seem to solve this thing for y, so I would distribute next. This will imply that y minus 6 is equal to 3/2 x times 3/2 times a minus 4. 2 goes into 4 2 times, and 2 times 3 is 6. That'll be minus 6. And then I'm going to add 6 on both sides, and notice what happens to the 6's. They actually cancel on both sides, leaving me with the answer y is equal to 3/2 x. Y equals 3/2 x is answer which one? C. All right, look at the next guy. Problem number 11. My goal here in terms of doing this whole final exam is to, one, practice some problems with you guys, and also to remind you of some formulas that you need to know. This is an absolute value inequality. There are 3 forms on how to solve an absolute value. So this one is, solve the absolute value of 3x minus 6 minus 2 is less than 10, and express the solution in interval notation. So now I'm actually going to bring out an extra piece of paper here just to remind you of the 3 forms of absolute value that you need to know to be able to solve an absolute value. So when you have the absolute value of x equals a number b, because when you take the absolute value of numbers, if they're negative, they become positive, and if they're positive, they stay where they're at. You can get 2 equations out of this thing, the plus equation and the minus equation. So when you got the absolute value of x equals b, that implies that either x equals b or x equals negative b. So you got to drop the absolute value, but you got that plus or minus situation here. Absolute value of x greater than or equal to works the same way. If I got the absolute value of x is either greater than or possibly greater than or equal to b, doesn't matter if it's equal to or not. If it's greater than, you do the same thing. Either x is greater than or equal to b, you basically just rewrite it without the absolute value, just drop the absolute value. Or, but when you introduce the negative, you got to switch the signs. X is less than or equal to the negative b. So it follows the same pattern. The special case one on absolute values is this. The absolute value of x is less than or possibly equal to b. When you have an absolute value less than, you have what we call the double-sided inequality. That implies that negative b is less than or possibly equal to x, which is less than or equal to b. And it's one of those double-sided inequalities where you solve for x in the middle. So these are the 3 equations you need to know for absolute values. Let's see which one this is. The big deal about absolute values is you got to get the absolute value by itself. So my first move on this particular problem, I got the absolute value of 3x minus 6 minus 2 is less than 10. The first thing I'm going to do is add 2 to get the absolute value by himself. Add 2 to both sides. This is going to give me, and I'll write it over here, the absolute value of 3x minus 6 is literally less than 10 plus 2, which is 12. Now, which type of absolute value is this guy? This is absolute value less than. This is actually case number 3. I'm going to do the double-sided inequality because it's absolute value less than. So the double-sided inequality would imply that I'm going to get negative 12 is less than 3x minus 6, which is less than 12. This is that double-sided inequality thing there. Now, just solve for x in the middle. Solve for x, I'm going to add 6 to all sides. This is going to give me negative 12 plus 6 is minus 6 is less than 3x because the 6 is canceled, which is less than 12 plus 6, which is 18. Last thing I'm going to do is divide by 3. Negative 6 divided by 3 is negative 2 is less than x, which is less than 18 divided by 3 is 6. So my answer, because it's not equal to, is between negative 2 and 6, not including the endpoints. Interval notation, that's between negative 2 and 6 with parentheses around it. So the answer is negative 2 to 6, which seems to be answer C. Take a look at the next guy. Find the center and radius of the circle. When you're talking about circles, what formulas do we need to memorize? For the circle, you want to put it in x minus h squared plus y minus k squared equals r squared. This is an equation of a circle where the center is the point hk. But notice, to get this hk inside the parentheses, you take the opposite. You got minus h, so you just basically switch the sign of the h and you switch the sign of the k. And r is the square root of the r squared radius there. But the big trick on this one is this. This x squared plus y squared minus 8x minus 6y minus 24 equals 0 is not an x minus h squared plus y minus k squared equals r squared format. How do I convert these long polynomials into x minus h squared plus y minus k squared equals r squared? I have to do what? Complete the square. All right, so let's complete the square. To complete the square, you want to get all the x's together. So I've got x squared, and I'll put the minus 8x beside it. X squared minus 8x, leave a little space, plus y squared, group it with a y, minus 6y is equal to, add the constant to the other side, equals 24. How do you complete the square? You take 1/2 the b term and you square it. So I'm going to take 1/2, what is the b term on the x's? That's the coefficient in front of the x term. So you take 1/2 the b term and you square it. And that's the number you add to both sides. So this would be 1/2 of the b term here is negative 8, 20 squared. What's half of negative 8? Negative 4 squared. What's negative 4 times negative 4? 16. That's your magic number that completes the square on the x's. Add 16 to both sides. What I do to one side, I do to the other. Now you got to complete the square on the y's. So now I'm going to take 1/2 the b term on the y's, which is the negative 6, squared. What's half of negative 6? Negative 3, squared. It's negative 3 times negative 3. 9. So I'm going to add 9 to both sides. Now when I do this, and let me blow this up for you guys in the back. When I do this, it makes these quadratic parts for the x's and the y's perfect squares. They're going to factor perfectly. Doing the anti-full thing on the quadratic on the x's. X squared is x times x. What times what is 16 that adds up to be 8? 4 and 4. And because the term's always a plus, but since the middle term is a minus, both these guys have to be minuses. Plus, complete the square on the y's. You got the y squared minus 6y plus 9. When you factor it, you're going to get y. And what times what is 9 is 3 and 3. And since the middle term is minus, it'll be minus in both terms. equals, and we're going to add this up, 24 plus 16 plus 9. 24 plus 16 is 40 plus 9 is 49. So when I rewrite this, when you multiply the same thing times themselves, that's called perfect squares. So this gives me x minus 4 squared plus y minus 3 squared equals 49. Now, to figure out the center, work inside the parentheses. But remember, inside the parentheses, always take the opposite. So I got x minus 4. So what is my h coordinate? Positive 4. I've got y minus 3 squared. So take the opposite. What do I get? 3. So the center point is the point 4, 3. And what's my radius? That's the square root of 49, which is equal to 7. So my center is the point 4, 3. And my radius is 7, which makes the answer D. Let's read the next question. Again, as I'm doing this stuff, you should also be taking notes on not just how to do it, but what formula am I using? This was complete the square. Number 13 says this. Find the vertex of the parabola of the graph of the function f of x equals x squared plus 16x plus 60. If you have a quadratic equation, so here we go, let me just pull this up here, because I'm pulling notes for you guys. If I have y equals ax squared plus bx plus c, what's the formula for the vertex? Well, the vertex is traditionally something called hk, that's going to be my point, but h has a special formula. H is equal to negative b over 2a, comes from the quadratic stuff. And k is equal to f of you plugging in this negative b over 2a into your function. This is the formula for the vertex. And one other thing. If a is greater than 0, it means your parabola is going upwards, which means you have a minimum vertex. And if a is less than 0, that means I have an upside down parabola, which means I have a maximum vertex. So, to get the h coordinate off this guy, the formula is negative b over 2a. In this problem, what's a equal to? 1, b equals 16, and c equals 60. So, h is equal to negative b over 2a, which would be negative 16 over 2 times 1. That's negative 16 over 2, which is negative 8. So the vertex is negative 8. Well, that means that A and B are not going to be my answers. Answer either C, D, or E. How do I get the K coordinate? The K coordinate would be f of the x coordinate, which was negative 8. This will be negative 8 squared, just plug it into your function, plus 16 times negative 8 plus 60. And that's a wonderful time to break out the calculator on this one. So this will be parentheses negative 8 squared, which is 64, plus 16 times negative 8 plus 60, which is negative 4. So my vertex H is negative 8, K is negative 4. So I got the point negative 8, negative 4, which is answer E. Again, don't be frustrated by the fact is that there seems to be no room to do these problems. They gave you lots of room on this next exam. So they were trying to save paper this semester or something or other. All right. Take a look at the next question. The profit a vendor makes by selling X pretzels per year is given by the function P of X is equal to negative 0.004x squared plus 2.8x minus 200. How many pretzels must be sold per day to get the greatest profit? Another word for greatest is the word maximum. And anytime you guys see the word max and min on this exam, you should be thinking vertex. And because the x represents pretzels, we want the x coordinate, which is also known as h, which is the formula negative b over 2a for the vertex. The max or greatest or minimum or whatever is max min means you're looking for the vertex. So in this particular problem, a is equal to negative 0.004, b is equal to 2.8, and c equals negative 200. Plugging it into the x coordinate called h of my vertex form, this will be negative b, negative 2.8 over 2 times a, 2 times negative 0.004. And x represents the number of pretzels, so once I crunch this out, that's what they want. How many pretzels do we need to sell? So this will be negative 2.8 divided by, don't forget parentheses in your denominator, numerator or denominator, 2 times negative 0.004. Close parentheses for your denominator. How many? 350 pretzels. So the answer is 350, which is answer B. Does that make sense? Take a look at number 15. 15 is a calculator question. Read the question and then let's answer the question. Which of the following function has no real zeros? This is a definition question. Well, no real zeros. What exactly is a zero? What's a zero also known as? Also known as a root. What is a root also known as? X-intercept. Root, zero, x-intercept are the same thing. The places that cross the x-axis. So when I'm going to sit there and find the function that has no real zeros, that means I don't have any x-intercepts. How do I tell if a graph has, a function has x-intercepts? I'm going to graph it. So we are going to graph these guys. So I'm going to go to clear my calculator and clear out my function here. Go to y equals. Type in the first one. 4x squared minus 2x minus 1. Zoom 6. Does this thing have an x-intercept? How many? 2. It crossed the x-axis twice. That's not my answer. B, y equals 4x squared plus x, and then I'll delete the rest of this mess. And I'm going to hit zoom, standard, zoom 6. Does this thing have an x-intercept? Yes, it does. It comes down here and just hits the point whether it crosses or touches, it's still an x-intercept. So this would not be my answer. Y equals, try this one. Negative 4x squared minus 2x plus 1. Does this thing have an x-intercept? Sure does. How many? 2 of them. No, that's not it. Let's go to y equals next guy. Y equals 4x squared plus 2x plus 1. Does this guy have a root? 0 x-intercept? No. Why not? Does this graph cross the x-axis? No, it keeps a little gap there. So this guy is going to be my answer, D. But I just want to prove it to you. Let's look at the last guy. Y equals 4x squared minus x. And does this thing have an cross the x-axis, or at least touch the x-axis? It sure does. There's no gap there. And if you needed to, you can always zoom in on the thing if you're not real sure. You'll watch it come down here and hit the point. It actually has 2. Does that make sense? So this was honestly a calculator question where you actually had to graph each of your answers to figure out the solution. But you also had to know the definition. 0 is the same thing as a root, same thing as an x-intercept. A piecewise function is defined by the following. F of x equals x squared plus 4 over x plus 2 if x is not 2, not negative 2. And if x is negative 2, you get x minus 3. They want to do this. They want me to calculate f of negative 2 and then add it to f of 4. When it comes to a piecewise function, you have to basically figure out which piece of the piecewise function you'll plug into. You only get to plug into one piece of a piecewise function. Inside the parentheses tells you what x is. If I want f of negative 2, x is negative 2. Which piece, top or bottom, do I get to plug into when x equals negative 2? The bottom one. So this would be plugging x is negative 2. This would be negative 2 minus 3. We'll clean that up in a minute. Then we're going to add it to f of 4. This means x equals 4. When x equals 4, that means it's not negative 2, which means I plug it into the top equation. This would be 4 squared plus 4 over 4 plus 2. So, crunching some numbers here, minus 2 minus 3 is actually minus 5, plus 4 squared is 16, plus 4 is 20, divided by 4 plus 2, which is, let's see, 16 plus 4, yeah, that's 20, divided by 6. Well, this is disheartening, because I'm getting fractions on this thing here. Did I do it right? Oh, thank you. Ah, that's helpful. It's negative 4. I wasn't paying attention there. It's negative 4. So negative 4, quantity squared, plus 4 over x is negative 4 plus 2. Yeah, watch what you're plugging in there. So x is negative 4. Negative 4 squared is actually 16 plus 4, but negative 4 plus 2 is negative 2. So that'll be divided by negative 2. So this is negative 5, plus 20 divided by negative 2 is negative 10. Negative 5 plus negative 10 is the same thing as minus 5 minus 10, which is equal to negative 15. The answer is negative 15, which is answer B. Does that make sense? Problem number 17. Given the graph of y equals f of x, which is sketched right here, using the techniques of shifting, stretching, reflecting, called graph transformations, decide which of the following is going to be the graph of y equals negative 2 times f of x minus 3 plus 1. Let's talk about that. Y equals negative 2 times f of x minus 3 plus 1. This is that techniques of shifting, stretching, and reflecting. First thing you want to do is order of operations. Order of operations works inside the parentheses. Inside the parentheses is what we call the horizontal shift. So, I see x minus 3 inside my parentheses. I see that minus 3. But horizontal inside parentheses has the opposite effect. Because I see a minus 3 horizontally, that means it runs left or right. Which way is this thing going to shift? Right 3 units. That minus 3 actually takes it right 3 units, right 3 right. Okay? And now that plus, now we're going to do multiplication. This is called the stretch reflect. What is that negative 2 out in front of the function going to do for me? The negative reflects it across the x-axis, aka flips it upside down, but that 2 has a stretching effect. So it stretches it out by a factor of 2 flipped upside down. Stretch by 2, which doubles the size, stretches it out, and flips upside down. And the last thing is you got your vertical shift, which is that plus 1. What's a plus 1 going to do for me? It works exactly the way you want it to. Plus 1 means it's going to go vertical, up or down. It'll go up 1 unit. So I've got to take this thing. I'm going to shift it right 3 units, flip it upside down and stretch it out, and then move it up 1 unit. Which one of these graphs takes the graph and shifts it right 3 units, flips it upside down, and then shifts it up 1 unit. Well, there's only 2 graphs that actually flip this thing upside down. This is a V graph this way, so if I flip it upside down, the V's at the top. So it's either, well, actually 3 graphs. It's either this one, or this one. Which one seems to move this thing right 3 units, shifted, and it's been stretched out by a factor of 2, which means you elongated it, pulled it together. So this thing, if I pull it together, it's going to be a little crunchier. And so the real answer is which one? A. Because that 2 stretched it out and then it moved it up, like you said, 1 unit. This one's been moved up 1 unit, but this is flattened out. A stretch would actually elongate it. So this has got to be my answer. All right? You and I both know this next problem is going to be on your test, your final exam. It's a classic quadratic. They love 2 different kinds of inequalities. They love quadratic inequality and rational inequality. I know you're going to have at least one problem of each type on your final exam. So here is the quadratic inequality. I want to solve this thing. I'm going to reuse up here because I got space. X squared minus 3x is greater than or equal to negative 2. It's a quadratic inequality. But here's the deal. Whether it's quadratic or rational, you always do the same thing. You always pull everything to one side and set it to 0 because you're looking for that plus minus stuff. We're going to do a number line on this thing. So set it to 0. So I'm going to add 2 to both sides. This will give me x squared minus 3x plus 2 is greater than or equal to 0. Now I'm going to solve for it like it's equal to 0. So I'm going to set this x squared minus 3x plus 2 equal to 0, and I'm going to factor it. X plus, see, x, it's x and x, 2 and 1, and because the middle term's minus, both terms have to be minus. Last term was plus, so it factors into x plus, x minus 1 times x minus 2 equals 0. Set each factor equal to 0. I get x minus 1 equals 0 and x minus 2 equals 0, meaning x equals 1 and x equals 2. Here's my question for you. These are the zeros of your equation. Do you want the zeros of your equation in your solution set? Yes or no? Why? Because of it being equal to on the original inequality. That equal to means I want these guys. And I'll put a little filled in dot to remind me I want these guys. So I'm going to draw myself a little number line. And I'm going to put my 2 zeros on there, 1 and 2, and filled in dots, because that means I'm going to have bracket for answers. Which means, well, they all have brackets, so that doesn't really help me out here. But that's all right. I never know. On your test, they may have a parentheses, then I could have omitted that answer. Now I'm going to do test values. Remember, my function was, as we set it to 0, would be x cubed minus 3x plus 2. We're going to do test values. Pick a number less than 1 and use your brain. Good choice, 0. F of 0, plugging in 0. 0 squared minus 3 times 0 plus 2. 0 squared minus 3 times 0 plus 2. Plugging in 0 kills off all my terms except 2. I don't care what the number is. What's the sign of it? Positive. Now, pick a number between 1 and 2. I'm sorry, but yeah, we got to go fractions on this. I'm going to pick 1.5. And I'm going to plug it into my function. I'm going to have full use of my calculator on this exam. So I'm going to plug in 1.5. Parentheses, 1.5 squared minus 3 times 1.5 plus 2. And I get negative 0.25. Don't care what the number is. What's the sign of it? Negative. Now I'm going to pick a number bigger than 2. I choose 3. Plugging in 3 squared is 9. Minus 3 times 3 is 9. 9 minus 9 is 0 plus 2 is 2, which is back to positive. Now look at that inequality. Remember, this is my original question. X squared minus 3x plus 2 has to be greater than or equal to 0. Greater than or equal to 0. What kind of numbers am I looking for? Greater than 0. Positive numbers. So where's it positive at? over here on the left, and on the right. So writing it in interval notation, this would be negative infinity to 1, bracket, because we want to include that point, union, bracket, 2 to infinity. You've got brackets on these numbers, which is one of these guys is negative infinity to 1, union 2 to infinity. It looks like it is this dude here. Not sure C. Does that make sense? And be careful, take your time in making sure you pick the right answer. They try to throw different questions at you guys that you may not have seen but should be able to handle if they give you one. Here's one. The graph of f of x is equal to a times x minus 2 times 2x plus 1 and passes through the point 3, negative 7. Find the value of a. Well, this is that functional notation stuff. They gave me a function, and they gave me a point it passes through, so they give me the x-coordinate, and they're giving me the y-coordinate. So I'm going to take my equation, plug in the x, and set it equal to the y. So when I do that, I'm going to get basically my function, which is a times x, which will be 3 minus 2, times 2 times 3 plus 1, is got to be equal to the functional value, which is negative 7. I'm plugging in x is 3, and I'm setting it equal to the functional value, which is negative 7. Watch the careless errors here. These are parentheses, so I'm going to work inside the parentheses. This will be a times 3 minus 2 is 1. 2 times 3 is 6 plus 1 is 7, equals negative 7. 1 times 7 is 7, so 7a equals negative 7. So solving for a, I would divide by 7 on both sides, and that gives me a equals negative 1. So the answer is B. A's got to be negative 1. Domain. Let's talk about restrictions first. All the things you've had that have restrictions, and then we'll talk about this problem. Domain. You are not allowed to divide by what number? 0. That's a domain restriction. So if you got a fraction, the denominator cannot be equal to 0. Second thing, with even radicals, square roots, fourth roots, sixth roots, you can't take the square root of what kind of numbers? You can't take the square root of a negative number. You can only take the square root of positive numbers or 0. Your third, logarithms. Logarithms. You can't take the log of negative numbers, nor can you take the log of 0. So remember, your domain restriction on logs is you can only take the log of positive numbers. So whatever you're taking the log of, make sure it's greater than 0. Okay? These are your big restrictions in terms of college algebra. So, we want to talk about the domain of this guy. I got g of x is equal to the square root of 2 minus 3x. What's the domain? Well, remember, with a radical, square roots or even roots, whatever's underneath the radical has to be greater than or equal to 0. If this was an odd root, cube root, fifth root, whatever, the answer is going to be all real numbers. Domain is all real. You can take cube roots and negative numbers. Cube root of negative 8 is negative 2. That's fine, but even radicals, square roots, fourth roots, so forth and so on, what's underneath the radical? So that 2 minus 3x has got to be greater than or equal to 0. So I'll put my little line here so we don't get confused on this. Now you got to do is solve for x to get the domain. To solve for x, I'm going to subtract 2. So I get negative 3x to be greater than or equal to negative 2. Then I'm going to do something or other that should bring up alarms. I'm going to divide by negative 3. The negative 3's cancel, but when I multiply or divide by a negative, what do I got to do? Switch the sign. So instead of greater than or equal to, it'll be less than or equal to. Negative 2 divided by negative 3 is a positive 2/3. Now x is less than or equal to x is less or equal to 2/3 means that here is 2/3. And I want that point because it's equal to, but I want less than or equal to. So in interval notation, this would be from negative infinity to 2/3 with a bracket on it, which is which answer? C. Now I'm trying to work this exam just like I expect you guys to work it, except I'm being long-winded on trying to prepare you guys with formulas and stuff like that. But if you look at it, worked exactly 1 hour into this exam, and I've already gone halfway through it. So most people finish up the college algebra final exam in about 2 hours. But how long do you have in case you want to double check your answers or whatever the case may be? 3 hours. You've got time to do this thing. Here we go. Find the midpoint of the line segment that connects these two guys. Well, again, the midpoint formula will be on the front page of this exam, but I mean, if I got to flip back and forth to look up formulas, that's going to eat up some of my time. The midpoint formula is very simple. If you got 2 points, x1, y1, and x2, y2, the midpoint would be, the x-coordinate would be x1 plus x2 divided by 2. And the y-coordinate would be y1 plus y2 divided by 2. It's literally the average of the x's, comma, the average of the y's. So for my x-coordinate, I got to add my x-coordinates up. So it'll be 4 plus negative 6 divided by 2. What's 4 plus negative 6? Plus a negative is minus 4 minus 6 is negative 2 divided by 2. And negative 2 divided by 2 is negative 1. Now let's go for the y-coordinates. y2 plus y1, that would be negative 3 plus 2. Negative 3 plus 2 divided by 2. Negative 3 plus 2 is negative 1 divided by 2. Negative 1/2. So my midpoint would be, literally, the x-coordinate was negative 1, the y-coordinate is negative 1/2. That is my midpoint, which is which answer? E. Yes.
Did you ask where the exams are? I don't see them going around anymore.
You got the exams back there. Bring them up here and pass them on this side because they got completely left over. Yeah, as many people, look at the pile of papers here. I got a lot of my students here. Well, a lot of other people's students. That's fine too. But all right. So how many people did not pick up their exam? Yeah, it seems to be the entire left side of the classroom, dude. All right. There you go. All right. Look at this particular problem here. It's another one of those kind of problems, so watch what I do here. Which of the following statements best describes the solutions of the equation x minus the square root of 3x minus 2 equals 4? I'm going to do this problem in 2 different ways. I'm going to show you how to do it a short way and a long way. But I'm trying to prepare you guys for the exam tomorrow. So the long way is the one you need to focus on. And I'll have the short way in my back pocket in case I need it. All right, so here we go. How do you solve? Instead of just figure out the type of solutions, let's just solve this darn thing and see what the solutions are. This is a radical equation, a square root equation. When you have a square root, an equation with a square root in it, the square root of, in this case, 3x minus 2. I got x minus the square root of 3x minus 2 equals 4. You want to get rid of the square root. You got to get x by himself, but I want to get rid of the square root. To be able to get rid of a square root, I got to get it by itself, and then I got to kill it off. What kills off square roots? Squares. So that's what I'm going to do. My first move is get the square root by himself and then square quote both sides of my equation. So I'm going to do this because I like positive square roots. So I'm going to add the square root of 3x minus 2 to both sides. This will cancel. That leaves me with x equals 4 minus the square root of 3x minus 2. I'm sorry, plus x equals 4 plus the square root of 3x minus 2. Then I'm going to subtract 4 from both sides. That's going to give me x minus 4 equals, this cancels, the square root of 3x minus 2. All I did was a little juggling getting that radical by itself. Now, once you get the square root by himself, what am I going to do? Square both sides. What I do to one side of an equation, I got to do to the other. So the trick is to square both sides. But you want to clean this stuff up. The nice thing about squaring a square root is they cancel. The square and the square root cancel, I'm left with just 3x minus 2. But I need to clean this guy up here. What is x minus 4 squared? X minus 4 squared, that square means multiply by himself. So that's x minus 4 times x minus 4. And if I wanted to clean this guy up, what method do I use? I have to FOIL it out because it's quantity squared. So when I do that, I'm going to get x squared, x times x, which is x squared, x times a minus 4, which is a minus 4x. Minus 4 times another x is minus 4x, and then minus 4 times minus 4 is a plus 16. Combining like terms and pulling it over here because of room, that gives me x squared minus 8x plus 16 equals 3x minus 2. Does that make sense? Where most students that have screwed this problem up is this. They got that x minus 4 squared. You know how they clean that up? X squared minus 16. The famous, they distribute the power. You only get to distribute power with restrict multiplication division. If you got a minus or a plus, you got to multiply it times themselves, and you got to fold it out. But once I fold it out, what a surprise. What kind of equation did the thing just turn into? A quadratic. X squared minus 8x plus 16 equals 3x minus 2. To solve a quadratic, you got to pull everything to one side and set it equal to your favorite number, 0. So I'm going to subtract 3x from both sides, and I'm going to add 2 to both sides. So this will be x squared minus 8x minus 3x is minus 11x. 16 plus 2 is 18 equals 0. Does that make sense? All right. How does x squared minus 11x plus 18 factor? And does it factor? What are the factors of 18? Well, let's see. What are the factors of 18? 18 factors into what? 1 times 18, 2 times 9, and 3 times 6. Which one of these guys adds up to be 11? 2 and 9. So I get x minus 2 times x minus 9 equals 0. Then I'm going to basically set each factor equals 0. X minus 2 equals 0. X minus 9 equals 0. That gives me x equals 2 and x equals 9. Does that make sense? How many solutions did I get? Maybe. Remember, when it comes to square root and logarithmic equations, you've got to check your answers. Also, when it comes to fractions, can't divide by 0. Fractions, square roots, and logarithmic equations, check your answers because you have domain restrictions. And I'm not checking to make sure it's right, which is always a good idea. I'm checking to make sure I don't violate a rule. This is a radical. I can't take the square root of a negative number. But let's check it out and let's see if it works. So I got x minus the square root of 3x minus 2. Does that going to be equal to 4? Plug in your numbers and watch what happens. If I plug in 2 into this thing, let's check it out. Plug in 2. This will be 2 minus the square root of 3 times 2 minus 2. Does that question mark equal 4? 3 times 2 is what? 6. Minus 2 is 4. So I'm left with 2 minus the square root of 4. Does that equal 4? What's the square root of 4? 2. What's 2 minus 2? And does that equal 4? 0. Does that equal 4? No. 0 does not equal 4. This is an extraneous solution. X cannot be equal to 2. It doesn't work the equation. With square roots and logarithmic equations especially, double check your answers. Let's check 9 out. Let's see if 9 works. All right, so if 9, here we go, I'm going to plug it into my equation. X minus the square root of 3x minus 2, does that equal 4? Plug in x is 9. 9 minus the square root of 3 times 9 minus 2, does that equal 4? 3 times 9 is what? 18 minus 2 is? Hold on, did I screw something up? 9. Yeah, 3 times 9 is 27, excuse me. 27 minus 2 is 25. 9 minus the square root of 25. Does that equal 4? Square root of 25 is what? So 9 minus 5. Does that equal 4? Yep, 4 equals 4. That checks. X equals 9 actually works. So there's only how many solutions? One solution. The answer is 9. Now you can go answer their question. What kind of number is 9? Positive. So the answer is C. The answer is one solution and it's positive. Does that make sense? Again, with radical and logarithmic equations especially, check your answers. And with fractions, just make sure you don't divide by 0 with them. Number 23. Suppose that you got the point 4, 3 is a point on a circle that has a center at the point -3, 4. Find the radius of the circle. What is the definition of radius? Radius is the distance between the center of the circle and the outside edge. Does that make sense? So what did they give me? They gave me the center and they gave me a point on the circle. So with the center and a point on the circle, to get the radius, all I got to do is find the distance. Do you guys remember the distance formula? It's on the front page if you forgot it, but it's something you should know. The distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. I think on the front page you use x1 minus x0, same difference, squared plus y1 minus y0 squared. So these are my 2 points. This is my first point, this is my second point, so I'm going to plug it in here. Distance would be the square root of, difference in that, 4 minus -3 squared plus 3 minus 4 squared. What is 4 minus -3? What's a minus negative? Plus, what's 4 plus 3? So distance is equal to the square root of 7 squared plus 4 minus 3 is -1 squared. 7 squared is 49. -1 squared is +1. The answer is the square root of 50. The radius is the square root of 50. Awesome. You'll notice here, though, that square root of 50 is not one of my answers. So they wanted you to clean up the radical. Break down 50. What's 50? What times what is 50? 2 times 25. And when you take the square root of that, with radicals, you can bust them up into multiplication division. That's the square root of 2 times the square root of 25. The square root of 25 is what? 5 square roots of 2. The answer is 5 square roots of 2. The answer is C. Oh, by the way, I wanted to show you this last problem. I was going to show you the easy way of getting the answer. Do you guys want to see the easy way of getting this answer? It's called graph theory. If I'm trying to figure out the type of solutions I have, let's look at the graph on it. Graph one side and graph the other, and where's the answer going to be at? Point of intersection. So I could have cheated on this problem. It's not cheating if you get the right answer in terms of using knowledge. X minus the square root of 3x minus 2. Okay? All right, graph one side, and now I'm going to graph the other side, which was 4. And I'm going to do a zoom 6. That's a -10 by 10, -10 by 10 screen. And I'm trying to figure out the point of intersection. Where does the two graphs cross each other at? That point right there. I can go second, calculate, and talk about intersection. Is slide it over so you can see the cursor. Is this the first curve? Yes. Is that the second curve? Yes. I guess the answer is right about there. And it tells me the point of intersection is 9, 4. But remember, you're solving for x. So x equals 9, which is exactly what we got. Do you see any other points of intersection? You can actually change the window and go out to, for x's, out to 20. And you won't see any more intersection because it keeps on going straight up. There's only one point of intersection, and it's a positive point. So I can look at the graph and tell you that. Does that make sense? Things to check yourself out with in terms of this stuff. Next problem here. Problem number 24. Find the value of, okay, first off, f of x is the square root of 2x minus 1, and g of x is equal to x squared minus 3. Find the value of g composed with f of 3. Before I find that, just for practice, and you should always do this, let's find the value, what the function of g composed with f of x is. Remember, this is that open circle compositional function. That means you're going to plug one function into the x of the other function. It's all about who's on the outside, who's on the inside. On this one, g's on the outside, f of x is on the inside. So g is your commander. The function is going to look like g, which is something squared minus 3. That's what g looks like. I just left a blank where the x is at. So it is something squared minus 3. But inside inside that parentheses where the x is, I'm going to put the entire f function, which is a square root of 2x minus 1. You can clean this up. The square root and the square do what to each other? Cancel out. This leaves you with g composed with f of x to be equal to 2x minus 1 minus 3, because the square and the square root cancel. And so cleaning it up one more time, g composed with f of x is going to be 2x minus 1 minus 3 is minus 4. But that wasn't the real question. That just gave me the function. What do they want me to do to this problem? They want me to find g of f of 3. So what am I going to do to find g of f of 3? I'm going to replace the x with 3. This will be 2 times 3 minus 4. 2 times 3 is 6, minus 4 is 2. The answer is E2. But remember the composition of functions, plugging one function into the x of the other function. Problem number 25. Find the domain of the function x plus 1 over 2x squared minus 8. The domain. Remember, the domain is always all real numbers except 1, if I'm dividing by something, I can't divide by 0. 2, if I have a square root or an even root, I can only take the square root or even roots of positive numbers or 0. And when it comes to logs, I can only take the log of positive numbers. This is not a log equation. It is not a square root equation, but it is a division equation. So where's my problems going to be at? The denominator. So I'm going to take the denominator, 2x squared minus 8, and I'm going to set it equal to 0 and figure out where I'm going to have what we call vertical asymptotes, the points that don't exist in my function. Well, this guy, I can factor out the 2. That leaves me with x squared minus 4 equals 0. And x squared minus 4 is a famous difference of squares. How does x squared minus 4 factor? X plus 2 times x minus 2 equal to 0. Set each factor that has an x in it equal to 0. This will be x plus 2 equals 0 and x minus 2 equals 0, which means x cannot be negative 2 and x cannot be equal to 2, because that would make me divide by 0. So my domain is all real numbers except plus or minus 2. So which one of this answer is it? D. Because if x is 2 or negative 2, that would make me divide by 0. Take a look at number 26. For the function f of x equals 5x minus 3 divided by 8, find the inverse. Remember your steps on finding inverses. You're guaranteed to have to find at least one inverse on this exam. All right, to find inverses, step 1. Change your function from f of x to y because it makes it easier. You can also check, make sure it's 1 to 1, but this is a linear equation, x to the first, so it's 1 to 1. So if it says find the inverse, here, change the function to y, so I get y equals 5x minus 3 divided by 8. Your next step is this, and this is what all inverses are all about. Switch the x and y coordinate. When you hear the word inverses, to replace function with y and then switch the x and y coordinates. When I switch the x and y coordinates, this is going to give me x is equal to 5y minus 3 divided by 8. Now your mission is to solve for y. If I got x equals 5y minus 3 divided by 8, how would you solve for y? What would your next move be? Multiply by 8. Get rid of those fractions. Multiply both sides by 8. 8's cancel here. I'm left with 8x equals 5y minus 3. Then my next move would be to add 3 to both sides. This is going to give me 8x plus 3 equals 5y. And then the last thing I'm going to do is divide by 5. That gives me y is equal to 8x plus 3 divided by 5. And last step is replace it with the inverse. So f inverse of x would be 8x plus 3 divided by 5, which is answer which one? 8x plus 3 divided by 5. Answer is B. Does that make sense? Questions? Now this one, I'm gonna need a little more room on this one. So I'm gonna go for my famous scrap sheet of paper, but I want you guys to emphasize this. They're gonna give you two different kinds of inequality problems on your final exam. One is a quadratic inequality. You gotta set it equal 0 and draw your number line. The other one is the famous rational inequality. And you have to set it to 0, get common denominators, and then basically do this. This one's kind of nice because they went ahead and just made it one big fraction. But if it was like 2 over here, if you have 3x plus 7 over 14 minus 7x is greater than or equal to 2, you would have to subtract 2. You've got to make sure that your equation is equal to 0. So they're going to hit you on one of these guys tomorrow as well. So I've got 3x plus 7 over 14 minus 7x is greater than or equal to 0. They went ahead and were nice enough to set it to 0 for me. So let's figure out what the solution is for this thing. Now, first thing you want to talk about is finding the 0. To find the 0, you're going to take the equation 3x plus 7 over 14 minus 7x and set it equal to 0. Let's solve. To solve, when you have a fraction equal to 0, is multiply both sides by your denominator. I'm going to multiply both sides by 14 minus 7x. This would cancel. That leaves me with 3x plus 7 equals 0 times anybody is 0. So when you're looking for zeros, it's just like setting the numerator equal to 0. Solving for x, I would subtract 7. Gotta love these wonderful fractions they gave these guys. So 3x equals negative 7. Then I would divide by 3, and I get x equals negative 7/3. Here's my question for you. This is your 0. Do you want your zeros in your solution set? Yes or no? How do you know? Because you have an equal to on your inequality. When it's equal to, you want your zeros. So that's a filled in dot, which means I want to include this guy. Okay? Now, you also have to exclude what we call the vertical asymptote. When you got a fraction, the vertical asymptote is where the denominator is equal to 0, as long as it doesn't have any common factors. So, the vertical asymptote, this one doesn't have any common factors here, so I'm going to take the 14 minus 7x and set it equal to 0. Solving for x, I subtract 14 from both sides. I get negative 7x equals negative 14. Then I divide by negative 7 on both sides, and I get x is equal to negative 14 divided by negative 7 is a positive 2. But here's the deal. When it comes to vertical asymptotes, you always have to exclude these guys from your set, because this means this number 2 would be dividing by 0, and that's illegal. Does that make sense? You always omit the vertical asymptote. The zeros, you either include them or exclude them depending on the inequality, equal to or not equal to. Now, when it comes to these inequality types, you have to do the number line test. Test values. Put your vertical asymptote on there and your 0, but make sure you put them in order. Negative 7/3 is smaller than 2, positive 2. The negative 7/3 is an equal to, filled in dot. 2 is a vertical asymptote, always open circles. My equation, my function, shall we say, is 3x plus 7 over 14 minus 7x. And we're trying to figure out where it's greater than or equal to 0. So I'm going to do test values. Pick a number less than negative 7/3. Negative 7/3, just to let you guys know, is negative 2 1/3. Negative 2.3333. Pick me a number less than that. How about negative 3 or negative 4 or something wrong? That would be less than negative 2. Bigger the negative, the smaller the number. Plug it in. This will be 3 times negative 3 plus 7 over 14 minus 7 times negative 3. 3 times negative 3 is negative 9 plus 7 over 14. Negative 7 times negative 3 is a plus 21. Negative 9 plus 7 is a negative 2. 14 plus 21 is a 35. I get the answer negative 2 over 35, and I don't care what the number is. What's its sign? It's negative, so everybody in that interval is going to be a negative number. Now pick a number between negative 7/3 and 2, and use your brain. Good choice. 0. Plugging in 0, this will be 3 times 0 plus 7 over 14 minus 7 times 0. Cancel out, the zeros cancel out, so I'm left with 7 on top and 14 on the bottom. 7 over 14 is the same thing as 1/2. But again, I don't care what the number is. What's the sign of it? Positive. So everybody in that interval is going to be positive. Now, pick a number bigger than 2. I choose 3. Plugging 3 into my function, this will be 3 times 3 plus 7 over 14 minus 7 times 3. 3 times 3 is 9 plus 7 over 14 minus 7 times 3 is 21. 9 plus 7 is 16. 14 minus 21 is a negative, what? 7. So I get the answer negative 16/7. Don't care what the number is, it's negative. Now, they don't always alternate signs, so you got to really do these test values. But now, go answer the question. What kind of answers were we looking for on this problem? Greater than or equal to 0. We're looking for the positives. So, my answers are between an interval notation, bracket for the negative 7/3, and 2, but it has to have a parentheses. Which is which answer? Bracket negative 7/3, comma, 2, parentheses, is answer B. But you needed a lot of space to do this problem. On your exam, we spanned it out. We gave you guys space to do it. Does that make sense? Number 28. Again, you're doing these problems to review. Here's another classic problem about the rational zero or rational root theorem. Which of the following numbers does not belong in the list of possible rational zeros of the polynomial? All right, this is that P over Q stuff. The A0 or constant term is what in this polynomial? What's my constant term? 9. P are the factors of 9. What are the numbers that divide 9? Plus or minus 1, plus or minus 3, and plus or minus 9. AN is the leading coefficient. What is the leading coefficient of my polynomial on this thing? 2. Q are the factors of 2. What are the factors of 2? Plus or minus 1, plus or minus 2. So let's write down every possible way we can write a P over a Q. That's 1, 3, and 9 over 1. It's plus or minus. 1 over 1, 3 over 1, 9 over 1. It's also 1 over 2, 3 over 2, and 9 over 2. So these are plus or minus. These are all of the possible rational zeros. Plus or minus 1, 3, 9, a half, 3 halves, and 9 halves. Which one, and this one says, is not a possible rational zero? So out of these listed numbers, which one's not up here? 3 halves is up here, plus or minus. Negative 3 is up here, 3 is up here. Is 2/3 up here? 1's up here, clearly. Yep, the answer is D. 2/3 is not in the mix. So the answer is D. Does that make sense? P over Q. I got 3 halves, but not 2/3. All right? There are some problems. I know a lot of these problems have taken a little bit of time, but there's going to be lots of problems that are going to be short. The next couple of problems are very short. So, on your mark, get set, and go. Identify the horizontal asymptote. Horizontal asymptote is about the degree of the numerator versus the degree of the denominator. If the degree of the top is less than the degree of the bottom, then the answer is y equals 0. If the degree of the top is equal to the degree of the bottom, the answer is the ratio of leading coefficients. And if the degree of the top is greater than the degree of the bottom, there is no horizontal asymptote. What is the degree of the top? Degree is the highest exponent. What's the degree of the numerator? 1. What's the degree of the denominator? 2. And remember, when the degree of the numerator, we'll call it top, is less than the degree of the denominator, the bottom, then your horizontal asymptote is y equals 0. The answer is y equals 0. It's just knowing a theorem. The answer is C. Does that make sense? All right, on this one, identify the vertical asymptotes. How do you find a vertical asymptote? Basically, you look to see if there's any common factors. They went ahead and factored it for you. If anything cancels, if you have a term canceling from the numerator to the denominator, that makes holes in the graph, but not vertical asymptotes. But that's a 3x plus 1, that's a 3x minus 1. So nothing cancels here. So to find the vertical asymptote, making sure nothing cancels, you just set the denominator, x times 3x minus 1 equal to 0. Set the denominator equals 0, how to find vertical asymptotes. It's already been factored, so I said each factor, x equals 0 and 3x minus 1 equals 0. So one answer is x equals 0. Here I would add 1 to both sides, so 3x equals 1 divided by 3. This gives me x equals 1/3. So I get x equals 0 and x equals 1/3 are my vertical asymptotes, which is answer B. All right, again, good practice on these problems. Here's some of our chapter 4 questions, test 4 questions here, test 3 questions on the last part of the material here, which is from chapters, well, basically my class, it was from chapters, 5 through 8. This is the chapter 5, chapter 6 stuff. Solve the equation x cubed plus 6x squared minus x minus 6 equals 0, given that one of the solutions is -1. So if the solution is -1, where the polynomial equals 0, that also means this guy is a 0. I could factor it out by doing my synthetic division. Take the -1 solution and divide it into the coefficients of my polynomial, which is 1, 6, -1, -6. No term is missing. Skip a line, draw a line. What kind of remainder are you expecting on this answer? Because if it's a solution, you'll get a 0 remainder. Let's see if I don't get that. Bring down the 1, multiply. -1 times 1 is -1. Add 6 minus 1 is 5. Multiply -1 times 5 is -5. Add -1 minus 5 is -6. Multiply -1 times -6 is +6. Add -6 plus +6 is 0. And you block off the last dude because that's your remainder. And what a surprise, I get a remainder of 0. But we already know that 1 is one of my, x equals -1 is one of my answers. The other answers is coming from this quotient down here. That 1, 5, -6 represents the coefficients of a polynomial. This is the constant x and x squared terms. So this is the quadratic x squared plus 5x minus 6. To find where it's equal to 0, you set that guy, that polynomial, quadratic, equal to 0. And you'll notice that this thing factors. What times what is 6? That subtracts up to be 5. 6 and 1. So this would be x, x. 6 times 1 is 6, but when I subtract it's 5, and it's a minus because they got opposite signs. And since the middle term is plus, the bigger number is going to be plus. The smaller number is going to be minus. Then I solve by setting x plus 6 equal to 0 and x minus 1 equals 0. I get x equals 1, and I get x equals -6. So what are my zeros? Remember, x equals -1 was given to be a 0. So I get zeros of, and I'll put little pointy brackets around it like they did. I've got -1, 1, and 6. -1, +1, and it's going to be -6. Watch your signs there. -6. So which one of these guys is it? -1, +1, and -6? The answer is E. Does that make sense? Which of the following polynomials below have n behavior down on the left and up on the right and cross the x-axis at x equals -3 but touches the x-axis at x equals +3? Okay? Well, on this particular problem here, all right, so which one of the following? Well, first off, when they're talking about, touches versus crosses here, let's take a look at these guys here. The x-axis, okay, so across the x-axis, x equals -3. So my 0 is x equals -3, which means my factor is going to be, set it equals 0, it'll be x plus 3. We're talking about the multiplicity. When you cross the x-axis, you have an odd multiplicity. Odd multiplicity would be 1, 3, 5, something like that. The other 0 was x equals positive 3, which when you set it equals 0 gives me my factor x minus 3. But because you touch, when you touch the x-axis as a 0, you have even multiplicities. Which when I put this stuff together, that tells me I've got to have an x plus 3 raised to an odd power and an x minus 3 raised to an even power. So from that information, I can go ahead and start eliminating my multiple choice answers. It's x plus 3 to the odd. There's x plus 3 to the odd. And x minus 3 to the even. This is x minus 3 to the even. Okay? So this one has exactly that. This one has x plus 2 squared. X plus 3 squared. But x plus 3 is supposed to be raised to the even, raised to the odd power. So B is out. C, I have got x squared plus 3, and I got, let's let x plus 3 to the, that's understood to be first power. That's x plus 3, that's odd, that'll work. And x minus 3 is raised to the even power. So this is still a possibility. I don't know about this mess in the middle, but these two guys actually have an odd power on x plus 3, and even power on x minus 3. This one, x plus 3 cubed. X plus 3 is to the odd power, but x minus 3 has to be to the even power. That's to the first power. So this guy's off. And then the last one, this is x plus 3 to the first. That's an odd power. And I got x minus 3 squared. That's an even power with this extra stuff. So this is a possibility. Okay? But now let's talk about end behavior. If I'm down on the left and up on the right, down on the left, up on the right, what kind of degree do I have to have? What is the degree if I'm down on the left and up on the right? If they're in the same direction, they're an even degree. If they're in opposite direction, they are an odd degree. Down on the left, up on the right means I got to have an odd degree. To figure out the degree, you add up the exponents or the multiplicities on this thing. This is cube. This is to the first power. This is squared. That's 3 plus 1 plus 2. 3 plus 1 is 4 plus 2 is even. But to have this, I got to have an odd degree. So this guy's out. C, I've got x to the first, that's 1 power. X squared, that's a 2. 1 and 2 is 3. And 4. 3 plus 4 is 7. This is a possibility. This one, what is my power? This is x plus 3 to the first. X plus 2 squared, that's 1, that's 2, that's 3 of them. Plus 1 more is 4, plus 2 more is 6. This is an even degree. I'm supposed to have odd degree. That pretty much tells me my answer's got to be 6. But you know, this can get rather complicated in terms of these odds and evens and stuff. So I'm going to double check this thing by graphing it. It is parentheses x plus 3 times x squared plus 3 times x minus 3, raised to the 4th power. Okay, there's my function. And I'm going to do a zoom standard on it. Zoom 6, negative 10 by 10, negative 10 by 10 screen. And I'm crossing at negative 3. And I'm touching at positive 3. But you'll notice that I am down on the left and up on the right. This is definitely my answer. Does that make sense? So if you're in doubt, put it on the graphing calculator. But you got to make sure. It's tough to type in all these guys, but with the degree and multiplicities, you can actually start eliminating some stuff. All right, finally, some chapter 8 questions here. Logarithmic and exponential equations. So let's practice. I've got 3 raised to the x plus 7 equals 4. I want to solve for x. Where is x located at? In the exponent, in this case, a 3. It's in the exponent. There's only one thing in the universe brings down exponents, and that's logs. Now, I can use the natural log or common log or any kind of log I want to, but if you look at all the answers, always pay attention when you're doing a multiple choice test, not just to the question, but to the forms of the answer. What kind of logs does all the answers have in it? So I guess I'm gonna have to use the natural log to figure out which then. I mean, I could use any log I want, log base 3 if I wanted to, log common logs, whatever. But since all the answers have natural logs, I'm using natural log. So first thing, get the exponential by itself, determine the exponent, and then take the natural log of both sides. Natural log of 3 raised to the x plus 7 will be equal to natural log of 4. According to log properties, where the powers get to go when you take the log in front of it. The exponent gets to go out in front. So this would be x plus 7 times the natural log of 3 equals the natural log of 4. Now at this point, natural log of 3 or natural log of 4 are nothing but numbers. To solve, I'm going to go ahead and divide to get my x plus 7 by himself. Get that x by himself. So I'm going to divide by the natural log of 3 on both sides. This cancels. That leaves me with x plus 7 equals the natural log of 4 divided by the natural log of 3. And then to solve for x, I'm going to subtract 7 on both sides. That gives me x equals the natural log of 4 over the natural log of 3 minus 7. Natural log of 4 divided by the natural log of 3 minus 7. Who's got the minus 7 here? Oh, then we got an error problem here.
That's what we were thinking.
Oh, well, nope, it's there. Yeah, I got it. Okay, it's not there. But you'll notice that a couple of these guys have one big fractions. So they made you jump through one more hoop. So I got this thing. So let's write this as a common denominator, because this is over 1, right? So I can write it as the natural log of 4 over the natural log of 3 minus 7. I'm going to go for that natural log of 3 denominator, but whatever I do to the bottom, I got to do to the top. So this becomes the natural log of 4 over the natural log of 3 minus 7 natural log of 3 over natural log of 3. Write it as one big common denominator, and that gives you the natural log of 4 minus 7 natural log of 3's over the natural log of 3. This is a classic way they like to do algebra. So your answer wasn't there. Can you manipulate your answer to get one of the other answers? I had to go for the common denominator. Which one of the answers is this? Natural log of 4 minus 7 natural log of 3 divided by the natural log of 3. The answer is actually D. Does that make sense? Does that make you angry? Okay, good. Well, if worst comes to worst, you know what you do? Put this on your calculator and get a decimal. Put each one of these guys in your calculator and get a decimal. And the ones that have the same decimal, go with that theory. That's your answer. There's always a way of outthinking the question. Does that make sense? This is the kind of college level student we want. Number 34. Solve the equation log base 4 of x plus 3 plus log base 4 of x minus 3 equals 2. This is what I call a log type 1 equation. Logs on one side equal a number. You've got to combine logs. What does addition turn back into? Multiplication. So this turns into one big log base 4 of x plus 3 times x minus 3 equals 2. Now, and I'm going to put my little line over here for this problem. Here. All right. Now, I want to get rid of a log. Anytime you've got a log equation, you have the ability to rewrite a log equation using what we call the definition, or what I call my class, the smiley face definition, to get you guys to remember it. So if you ever need to rewrite a log equation without logs, you can understand it, smile at it. Start with the base 4, raise it to the other side 2. It'll be equal to what you're taking a log of, x plus 3 times x minus 3. Does that make sense? So, clean it up. What is 4 squared? 16 equals, now this I'm going to fall out because this is going to be a quadratic. X times x is x squared. X times minus 3 is minus 3x. 3 times x is plus 3x. And then minus 3, positive 3 times minus 3 is a minus 9. The inner adder ends up canceling. So you get this equation. 16 equals x squared minus 9. How would you solve for x if I got 16 equals x squared minus 9? There's no reason to factor it. Just solve for x. Get your x squared by himself. I would add 9. What's 16 plus 9? 25 equals x squared. But what do I got to do to get rid of a square? Square root. But remember, when you put a square root in a problem, don't forget plus or minus. So I'm gonna put the square root into it, but I gotta, anytime I introduce a square root, I gotta do plus or minus. So I get x to be equal to 5, and I get x equals -5, plus or minus 5. Does that make sense? But I want to remind you, there are 3 different kinds of equations you got to check your answer on. Fractions, check your answer, make sure you don't divide by 0. Square roots or square root equations, make sure you're not taking the square root of a negative number and make sure the answer works. And logarithmic equations, because you can't take the log of a negative number. So let's check our answers. Go back to the original equation. Plug in 5. If x is 5, what's 5 plus 3? 8. Nice and positive. What is 5 minus 3? 2, but it's nice and positive. X equals 5 is a winning answer. When I plug it in, I'm taking the log of positive numbers. However, what about -5? When I plug in -5 plus 3 is -2. I can't take the log of a negative number. This is an extraneous solution. That's not a solution. It doesn't check. Does that make sense? Because it makes me take the log of a negative number. But you'll notice here, they put plus or minus 5, -5, positive 5. The only answer is positive 5. Don't forget, on log equations, check your answers. All right? Let's see here. On this one, I'm going to work problem number 35 over here so you guys can see it. I got the equation log base 3 of 4x minus 1 equals -1. Okay? Again, that's a -1 there. Can't read my handwriting. It is a logarithmic equation, but they went ahead and combined all my logs for me. But if to solve a logarithmic equation, you got log equals a number, you want to rewrite it in the exponential form of logs, the smiley face definition. Question?
Can you make it bigger?
I can try. All right? So I'm going to rewrite this equation right here by doing what? Start with the base, raise it to the other side. It's always equal to what you're taking the log of. This is your definition of logarithms. You can always have the ability to rewrite a log equation. This will be 3 raised to the -1. That'll be equal to what you're taking the log of, which is 4x minus 1. Solve for x. What's 3 to the -1? That's the same thing as negative exponent goes on the bottom. 1/3 equals 4x minus 1. How would you solve for x if I got 1/3 equals 4x minus 1? I add 1 to both sides. 1 is 3/3 plus 1/3 is 4/3 equals 4x. And then I would divide by 4 or multiply by 1/4, and I get x equals 1/3. I could also do this on my calculator, just to show you guys. I could type in, if I'm kind of unsure about this, 3 raised to the -1. And then I'm going to add 1 to it. And then I'm going to divide that thing by 4. And that gives me this answer, and then I convert it to a fraction. I get 1/3. And hold, slide over, you guys can see this. There you go, 1/3. So which is which answer? Okay. All right, take a look at number 36. Use the rules of logarithms to rewrite the expression. I've got 3 raised to the log of x, natural log of x, minus 1/3 the natural log of y. Basically, they want to write this as a single log equation. In my class, just to enjoy ourselves and make fun of this stuff, I call this the Humpty Dumpty problem. We got Humpty Dumpty busted into a bunch of pieces here. Our mission is to put him back together again, using log properties. Addition turns back into multiplication. Subtraction turns back into division. And if you got a number in front, you got to put him back where he came from, which is back to the exponent. You're using your log properties in reverse. They go both ways. To be able to combine logs, the coefficient in front of the logarithm must be a 1. Because I have a 3 here, and I got a 1/3 here, that 3 has got to go back where he came from, which is the exponent. That 1/3 has to go back where he came from, which is the exponent. Which means this is equal to the natural log of x raised to the 3rd power, natural log of x cubed, if you will, minus the natural log of y to the 1/3 power. Now I've got coefficients of 1 in front of my logs. What does subtraction turn into? Division. One big natural log of division. The positive term, the x cubed, goes on top. The y to the 1/3 goes on the bottom. And of course, they're going to make you jump through one more hoop on problem recognition. What is a 1/3 power, also known as? Cube root. So this would be the natural log of x cubed divided by the cube root of y, which is which one? Answer is D. Does that make sense? They like to do these log properties of either take a log and bust him up or put him back together again. Make sure you know your log properties. All right, 4 more problems and then we're done. All right, suppose your math professor gets a one-time bonus for a stellar job he or she has done in teaching Math 1100. Well, God knows I deserve one, but I don't know about the rest of these guys. And decides to invest in an account that pays 8.5% interest, compounded continuously. Your professor calculates the account will grow to $8,188.76 in 10 years. How big was the bonus that they received? All right. First off, when you read these problems, you've got to figure out, this is that compounded interest rate. There's 2 formulas. You've got 2 formulas. They're on the front page of your thing, but you should know them. A equals P times 1 plus R over N raised to the NT, and A equals per. Which formula do I use when? This is regular compounding, but this is that special compounded continuously. Which form am I going to use? Because it has the same problem. It's either compounded every month or every week or every quarterly or something like that. That's regular compounding. But they said in this problem, this is what I'm looking for. Compounded what? Continuously. So what's my formula for this guy? A equals per. So as I read through this problem, we can have an interest rate. R is 8.5% interest, but remember percentages for people who can't do math. What is 8.5% interest? Move your decimal 2 places to the left, and what do you get? 0.085. 2 places to the left to get your interest rate. Now, your professor calculates the account will have, the amount in the account is $8,188.76 in 10 years, so my time is 10. The amount is how much did we receive? What is the principal? How much money do we have? So I'm going to plug this thing into this equation here. A was $8,188.76 equals the principal times E raised to the 0.085 times 10. And believe it or not, that's a 10 there, in case you can't read it. Does that make sense? Now, this is nothing but a number. We can clean this up. This is $8,188.76 equals PE to the 0.085 times 10. 0.085 times 10 makes it 0.85. This is E to the 0.85. E is 2.718, whatever. Raised to a 0.85, this is nothing but a number. How do I solve for P if I'm trying to solve for P? I'm going to divide. So I'm going to divide both sides by E to the 0.85. E to the 0.85. This is going to give me P, and I'm going to put this on my calculator, and I'm going to show you right here so you guys can see this. Put it over here. This is $8,180.76 divided by E raised to the 0.85. And what do I get? I got $3,499.98, which you can pretty much bank on. How much is that much money? $3,499.99.8. Might as well round it off. What is that? $3,500, which is answer C. Does that make sense? Questions? All right. But now compare that problem, and notice my formulas are still up there, to problem number 38. Find the cumulative value of an investment of $3,000. So that's how much I'm investing. That's my principal, $3,000. They pay 6%, 6% interest, which by mathematics is 0.06, compounded quarterly. Compounded quarterly is regular compound. And how many times a year is compounded quarterly? 4. So n would be equal to 4 and time for 8 years. So this particular problem, we would use this formula. A equals P times 1 plus R over N raised to the NT. Now, you know these formulas on the front page of your exam, but you got to know which letter means what. N is the number of times a year you compound, P is principal, R is your interest rate, T is time, A is the amount you get back. So when I plug it in, this is 3,000 times 1 plus 0.06 divided by N is 4 raised to the 4 times 8. And I'm just going to put that on my calculator. 3,000 times 1 plus 0.06 divided by 4 raised to the, and if you got the old style operating system, don't forget to put parentheses around your exponent. But I got the newer operating system, which actually puts it right into the exponent here. I can just do 4 times 8, all in the exponent. And how much money do I get? $4,830.97, which is, they seem to be rounding your answers off to the nearest penny, which would be what? $4,831? The answer is A. Does that make sense? Okay. Let f of x be equal to x cubed minus 2, and g of x is the cube root of x plus 2. All right? Square root and cube root of x plus 2. Choose the correct statement. F and g are both odd functions. F and g are inverse functions. The graph of f is the graph of x cubed shifted right by 2 units. G is decreasing on the interval between negative infinity to negative 2. None of the above is true. All right? So, let's just look at the graph of these guys. And I'm going to look at my calculator. Y equals, clear out the old one, x cubed minus 2. Let's look at the graph of that guy. Okay? And at the same time, I'm going to graph the cube root of x plus 2. But remember, cube root is the same thing raised to the what power? Cube root? 1/3 power. Cube root's 1/3, square root's 1/2. And I'm going to do a zoom standard on this thing. There's the cube root graph. And here comes my cube graph and cube root graph. You will notice something about this. First off, are these functions odd versus even? Even functions are symmetric with respect to the y-axis, which means the right half of the graph looks like the left half of the graph. Does either one of these graphs, the right half looks like the left half? No. Odd functions are symmetric to respect to the origin. The first quadrant looks like the third quadrant except upside down, and the second quadrant looks like the first quadrant except upside down. Do you have that situation going on? No. So odd and evens are completely out. So what about, I can take one graph and shift it over by 2 to get the other graph. No, I don't think if I shift this over by 2, I'm going to end up getting the other graph. If I flip it upside down or something or other, maybe, but nope. So is G decreasing on the interval between negative infinity to negative 2? G is actually increasing the whole time. So increasing meaning it's going up. But the only one here is, let's see here. The graph, let's see, the inverses. Oh, wait a minute. Excuse me, that's just odd functions. The question here is inverses. Are they inverses? Remember, when you're looking at a graph, inverse functions from a graph, inverse will be symmetric to the line y equals x. This is the line of symmetry of y equals x. So if I type in y equals x and graph it, you will notice that y equals x kind of splits these two guys down the middle. And I can zoom square this up so you can see this a little better. Zoom square evens up my screen so it looks a little better. There's the cubic graph. Here comes the cube root graph. And you'll notice that y equals x splits it right down the middle. So I've got this thing going on here. I got this thing going on here. And those, they are symmetric with respect to the y-axis. These guys are inverses. One other thing to prove that they are inverses. So the answer on this problem is actually B. They're not shifted over, they're not decreasing, and so either is B or none of the above. The other way you can check on inverses is this. If I take the composition of two functions and clean it up, and I get x out of it, f and g are inverses. So, remember, f of x was x cubed minus 2. G of x was equal to the cube root of x plus 2. If I take the composition of these two functions, that means plug one into the x of the other. F is on the outside, so f is my commander. Something cubed minus 2. If I plug in g of x inside my parentheses here, the cube root of x plus 2, and clean it up. If I clean it up and get x out of it, they're inverses. If I get anything extra than x, they're not inverses. What does the cube and cube root do to each other? They cancel. That leaves me with x plus 2 minus 2. What is x plus 2 minus 2? What happens there? 2's cancel. What are you left with? X. When the composition of the two combine and cancel, they are inverses. So these guys are inverses. And my graph also told me that too, if they're symmetric about the line y equals x. They're inverses. And then one more problem. And here is the deal. You've got to know one more definition. And that definition is this. What is the difference quotient formula? The difference quotient is this. F of x plus h minus f of x all over h. If you go to the front page of your exam, did they give you the difference quotient formula? Yes. They did? Oh, there it is. Thank you. I can stare at it all day long. I'll miss it. There it is. F of x plus h minus f of x all over h. So, difference quotient. This will be equal to, my function is f of x equals 8 minus 7x. So if you got f of x equals 8 minus 7x, what is f of x plus h? Remember, this is functional notation. I don't care what's inside that parentheses. Whatever is inside that parentheses is what I replace x with in the original f of x function. So as f of x equals 8 minus 7x, f of x plus h would be 8 minus 7 times replace the x with x plus h. Does that make sense? Just replace the x with x plus h. Now I'm going to plug it in here. F of x plus h is 8 minus 7 times x plus h minus f of x. F of x is just the original problem, parentheses, 8 minus 7x all over h. If I'm going to clean this thing up, I'm going to do a little algebra here. First thing I'm going to do is I'm going to distribute that negative 7. This will be 8 minus 7x minus 7h. And because of this parentheses, notice I have to use parentheses when I minus that function, that negative is going to distribute. That's minus 8 plus 7x all over h. What cancels? 7x is canceled. What else cancels? 8's canceled. What am I left with? Well, what's your sign? Negative 7h over h. What cancels? Strict multiplication division, the h is canceled. What am I left with? Negative 7, which means the answer is B. I hope this has been helpful, but I wanted you guys to see a final exam in its entirety of how to do it, and you should practice on these problems. But don't let this be the only exam you guys practice with. There are more online. If you go to www.math.uncc.edu, go to undergraduate resources, you'll see old common exams. Practice some other ones. Like I said, I hope this helps. Good luck, and I'll see you guys at 7:30 in the morning.